Hello one, welcome back to Aislyn Technologies YouTube channel. Today we're gonna see about key generation for zero steganography using DNA sequence. I'll explain our abstract first. Our abstract explains DGET is nothing but data encryption using genetic technique. It's an innovative encryption method that enhances the data security through multiple iteration genetic process. It employs three main operations. One is reshaping, crossover, and is mutation. In reshaping, it organizes data into structured chromosome population akin to DNA sequences. And crossover combines genetic material from parent chromosome using single point and rotation method to create a new offspring. Mutation introduces randomness by modifying the bits and converting them into DNA bases with enhanced genetic diversity. Decade features a large key space that makes it resistant to brute force attacks and observe any relationship with original data, thereby providing strong confidentiality. Its effectiveness against various attacks method has been experimentally validated, making DGET a reliable encryption solution for securely transmitting sensitive information in both images and text formats. In our introduction, it emphasizes the critical need for secure data transmission in digital world where sensitive information is vulnerable to unauthorized access and cyber threats. Traditional encryption methods are becoming less effective against evolving attack strategies, highlighting the necessity for more advanced technique. Papa presents DGET, that is data encryption using genetic technique, which uses genetic algorithms inspired by natural selection to enhance encryption. By incorporating processes like reshaping, crossover, and mutation into encryption, DGIT creates a dynamic and adaptable encryption framework. It utilizes DNA sequence to add randomness and complexity, making the encrypted data resistant to attacks. The problem Here, a problem statement explains that addresses the limitation of traditional encryption method, which struggle to maintain data confidentiality, integrity, or authenticity in the face of sophisticated cyber threats. It calls for innovative encryption solution that integrates biological principles and genetic algorithms to develop a robust, a multi-layered defense against various type of attack. Here, our objectivity is to aim to design, implement, and evaluate DNA genetic encryption technique as an innovative method for securing digital data. A specific, the specific objective include development of DGET, enhanced security mechanism, evolution of performance, versatility of data types, analysis of security features. I will explain you a flow chart so you'll have a good idea about this project. Yeah, here's a flow diagram. Yeah, here's our data. This is the text we want to encrypt, and this is the binary data. After binary data, it will be converted to DNA by using the function. I will explain the while I'm explaining, I will explain the full code so you have idea. After converting to DNA, we are giving a decryption key here. After giving a decryption key, we're converting it to an encrypted key. After ambiguity, we are reshaping it to a previous reshaped data. After reshaping, our result will be sent back to the function and then we will display the result here. Now I will show you a decryption Python file. Now I will explain you our encryption and decryption code. Yeah, here's our encryption code. In this code, the code primarily focuses on decryption. We can interfere the encryption process from cryptic key function and how it fits into overall workflow. In this function, the purpose is to perform a simple XOR operation between DNA sequence and then binary. Here, the function performs a simple XOR operation between DNA sequence, it's a binary data and encryption key. It is in the if the data length exceeds if the data if the data length exceeds the key length, the key is repeated to match the data length. The bitwise operation XOR operation is performed with the reversible, that is applying XOR with the same key again, retrieve the original data. In data, in decryption process is more complex. It involves several steps primarily. In DNA, the decryption of the given data sequence using probability. Here, the number of routes and known specific information is extracted from the key. The initial DNA sequence is encrypted text is stored in B data, and then the decryption occurs over a specific number of rounds. In each round, the steps will be occurred, such as the reshape, mutation, and crossover. In reshape, the reshape function, the DNA sequence is reshaped into a population of chromosome using reshape function that divides the DNA sequence in smaller part of chromosome, and a mutation function is over here. In mutation function, it applied to alter the chromosome function, and if we are doing a flipping bit here, that is the specified region of chromosome will be there, and replacing the DNA basis using mutation table for alter the original basis, and in crossover function, it will apply rotate crossover and a single point crossover to combine the crossover, which introduce variability and mimics the re- genetic recombination. Now I'll run this. Yeah, here it is a text which we wanted to encrypt. Now I will run this. Yeah, our text is in the computer science and operation research. Our key is this. This will be turn it as a DNA sequence as this, and the total time is executed is 0.4 seconds. Now run the decryption code. Yeah, in the decryption code, we are using a decrypt with key. In this decrypt with key function, in decryption, the crypted DNA undergoes the inverse process of reshaping, mutation, and crossover. Crossover. Here, the DNA undergoes the several process, and then it will reshape and it inverse the process of reshaping and mutation crossover. The DNA is decrypted back to the binary using XOR operation with the same key, and the binary data is finally converted into original data. Now I'll run this, so you will have a good attention of this. And see this. You can see our encrypted text it was here, and then we are reshaping it so that we have got this. Our decrypted text is in that computer science and operation research. This is our output. Yeah. I hope you are clear with this project. If you have any doubt about this, you can leave a comment in comment section, and don't forget to like, share, and subscribe. Thank you.